Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. Here is another one of these stair building tips that might not seem like it's the #1 best tip in the whole world, but it is something that could save you a lot of frustration as a do-it-yourselfer or even a professional home builder. And the situation I see all the time, whether I'm working on a project or driving by one, is that they will build the floor first and then install the stairway. And I'm here to tell you that you need to build the stairs first to locate the stair head out, and then build the floor if possible. If not, then it wouldn't be a bad idea to pre-cut your stair stringers to verify the measurements for your head out before you build the floor. So let's go ahead and take a look at what the stairway should look like. And you might be working on a project that has a set of plans. And the plans usually show the upper floor line and the location of the stair steps. However, most stair builders, including myself, rarely build them to those exact specifications. And a good example of that would be if we come down here. You'll notice that the front step right here does not line up with the edge of the stairs. However, this side here will line up. We'll take a look at that here after we look at the head out and the floor sheathing to provide you with an idea of where the last step will be located on the upper floor. And if you have a situation like this, you can build the landing and the steps below first, and then draw a line on the landing where you want the front of the stringer to line up with. And you could even install a block here if you need to prevent the stringer from sliding down while you're holding it up on the other side. And to find this position here, you're going to need to subtract for the width of the stair riser and the nosing if it's going to have one. And in this situation here, we're going to have a 3/4 inch thick riser with a 1 inch overhang, suggesting that this needs to be moved back at least 1 3/4 inches. And then after we have that, we can just simply cut one stair stringer. And if you have a situation like this, you can pre-cut the stair stringer and then use it to locate the stair head out or support beam. However, if that won't work for you, you can always have the stringer run a little longer and then line it up with the measurement you've selected that will work best for the upper floor framing. Because sometimes if you have a situation like this and it doesn't line up, you can recut the stair stringer, lay it out with smaller or larger steps, as long as they meet your local building codes. Again, providing us with a good reason why we only want to lay out one stair stringer. And like I already said, I can't tell you how many jobs I come to where the stair stringer is off an inch or more because somebody built the floor first or didn't know how to locate the stair head out. So if you're not really good with math, your stair stringer measurements might be off a little bit, or you're just looking for the easiest way to locate the support beam or stair head out in the floor framing, then this just might be your best option. In this video, I am going to try and build some stringers out of 2x4s. And for those of you wondering why I would use 2x4s when 2x12s are available, because you live in an area where there is plenty of lumber, I do have to point out that there are some places who have a difficult time getting larger lumber. So with that said, let's go ahead and see what we can do here. So as you can see, I have a couple of 2x4s that we are going to firmly attach together. I'll provide you with some ideas for that towards the end of the video. And in our first example, I'm going to keep it about the same size as the 2x12, which is going to create a problem with the small tip here. And that could cause the small part here to crack when you go to drive a nail in here. So if you do something like this, you might want to pre-drill a hole for a nail or a screw. Or if the piece is small enough, you might be able to build the stringer without it. However, don't fear. I've also created a couple of other examples where we can make this a little bit larger. Now, if you notice here, I have two full-length 2x4s, and I've created the stringer to where the point of the angle here, where the bottom of the riser and the tread meet, won't need to notch into the lower support board, which will end up providing us with a little stronger stringer. Now, even though I said that we're going to use 2x4s in the video, I want to point out that if you can get larger materials, it might be good to use them right here so you don't have to worry about the splitting, or at the very least you will have one less gap here to worry about. Now keep in mind that this area right here can crack also if you're going to be screwing or nailing into it. And that would go for any other part of the stringer where you come to a narrow point. And of course, it would be obvious that you couldn't do this if all you had access to were 2x4s, which means you might need to do something like this. Start from this point here, so that this is going to be 3.5 inches wide, providing you with the largest piece possible for your stringer, along with providing you with more structural support here. And another thing I need to point out, even though this would be obvious while you were building the stairs, which would be to make sure that you locate the support boards on the bottom at the far edge here, because if we leave it like this and there is any type of cracking, it could actually crack right here. So make sure that the stringer is fully supported here, and you can always use larger boards, and the same would hold true for the ledger. You can see where this needs to be a little bit larger, and if all you have are 2x4s, you can just nail a bunch of 2x4s in here to create your ledger. So you might need about 3 2x4s, 2x4 here, 2x4 here, and a 2x4 here, running the length of the wall to support the stair stringers. And I'm guessing that this right here, since it's going to be wider, is going to be about the strongest stringer you can build out of all of the examples I've provided you with in the video. And even though we have installed a larger block, if you do drive a nail anywhere into the treads, the stringers anywhere, and it cracks, then I would definitely start pre-drilling holes for all of your nails or screws. And you could always remove one of the 2x4s if you're going to be providing additional support like this. However, I wouldn't recommend removing this 2x4 here and just having these two. However, I will leave that up to you. I'm just throwing these ideas out there. And you can see here where we are using screws to attach everything. And I'm going to go ahead and provide you with an X-ray view here of the screws. Pre-drill some holes, and you could even countersink the screws if you wanted to connect the 2x4s together. And obviously, if you were going to do something like this, then all of these boards would need to be pre-cut. And there are plenty of ways to join boards together, and a couple of those might be using a biscuit jointer or some wooden dowels, along with adhesive at all of the breaks. And you could even use adhesive if you wanted to in your pre-drilled holes for your screws. Obviously, for your dowels, you're going to want to use some adhesive, and your biscuit joints. And it would be a good idea to position the screws or dowels away from any areas where you might be adding additional nails and screws. And some more ideas would be to use some type of building hardware or straps. And you might not need to pre-drill any holes in this area here, but you might need to up here where the board's getting a little shorter. Of course, you could always reposition the straps however you feel necessary, and even use 2x4s to nail all of the blocks together with, and plywood or OSB. And you could get as creative as you want here, obviously larger or smaller, and maybe even a support block like this might work in the middle of the stringer, especially if you are going to be creating larger stairways by using any of the methods shown in this video. And let's not forget that I have never physically built any of these, so if you build it and for whatever reason it does not work, do not shoot the messenger here. And I would also like to point out that something like this might work a lot better on the interior than it would on the exterior, where you could be getting a lot more moisture that could create problems for all of the joints where the pieces are joined together. While I was taking pictures in San Francisco one time, I took a picture of a stairway that kind of looked like this. I'm going to show you the picture at the end of the video, but it gave me an idea about using posts and concrete footings to provide additional support for the stair stringers and for the hand railing. With the posts and the footings, you're probably not going to be able to push the handrail from side to side very much. You're going to get a nice connection. So this right here is a good way to build something like this. Zoom in on the post and the footings. Make sure that the soil does not go, it's not touching the woods, which would require the footing actually to stick out of the ground a little bit. Go to the side here. We can see where the posts are connecting to the top of the handrail, or guardrail I should say, and this is a nice connection. Over here you're not going to have that as much. The post that is just attached to the stringer, especially if it's a 2x12, you're going to be able to move this. Am I suggesting that you're going to be able to move it enough to where you can push it over? Probably not with a construction like this. So would something like this work? Yes. It's just something like this on the other side is going to work better. Going to cost you more money. You're going to have to put the footings in. Understand that. But you know, if you build a stairway like this and the stringers are 2x12s, which they could only be 2x12s, a situation like this, the stringer would need to be a 4x12. A situation like this, the stair stringer could actually be a 2x12. Whether that would save you enough money to justify digging the other footings, if you're looking for something as cheap as possible, I would imagine 2 4x12 stringers with something bolted on the side would be the cheapest way to do it. But attaching 4x4s onto a 4x12 stringer would probably be fine in a situation like this. But this right here is going to be better for the handrail, because you're adding the support by connecting it to the stringer, whether it's a 4x12 or a 2x12. So if I was actually going to build a stairway like this, I would probably use the footings on the side of a hill with 2x12s and attach everything to the post. And if the wood starts to rot after a while, you can just replace sections of it. You don't need to replace, if you actually had a section, let me go back to this scene here. If you actually had, let's say, had water damage here, for a situation like this, you could actually cut a section of the stair stringer out and then replace that section without replacing the whole stringer. So something like this actually might work out great for a repair also. Here's the original picture. You can see the handrails. I kind of stayed to the design. And we have the posts. Hopefully they're not sitting in the soil, or any soil is touching the wood post. Big no-no. We won't look at that any closer. Try to avoid having plants growing through your stairs. A lot of people don't realize it, but something like this plant will provide shade and moisture for the wood. And over time, it can, if you don't do anything about it, the moisture, of course, is going to remain on the wood stairs longer. And of course, in San Francisco, I would imagine, where I took the picture, you have a lot of problem with areas like this that do not get a lot of sun. And if that's the case, absolutely no plants around them. Keep them away from the stairways to avoid any chance of moisture sitting on top of the wood. Here's a good example of what I was talking about, where the treads are are not in between the stringers. They're actually sticking out past. I don't like this. I don't think it would be a problem structurally, but of course aesthetically it just doesn't look nice. This provides us with another example of what I said, where the wood post is not connected to anything. This doesn't have a lot of strength to it. And then, of course, I will avoid talking about the different riser heights here and the trip hazard here at the bottom. But anyway, hope this gives you an idea. If you are going to build a stairway like this, these posts are an excellent way to build it. And here you can actually see, I don't know if they did this out of necessity, but let's just say that you had wood damage here. You could actually just cut it out here and replace just one section of it. Same thing with the stringer. You could just, if the upper section was perfectly fine, then just remove this section, replace it. And I would imagine for this stairway right here, you are going to have to replace this one here because I can see the dirt right there up against it. So big no-no. Here's another one of those crazy stairways I have seen built before. Never built one myself. Remember, I am not an engineer. I do not guarantee that something like this will work. I mean, the last thing I want to do is provide you with something and tell you that you can make this 50 foot long. I cannot guarantee that. Would something like this hold up if it was made out of 4 or 5 steps? I don't think it would be a problem. But when you get to where you're building a stairway that's even this size, it could be. And I would hate to tell you can build something like this without any engineering on it. Just ain't going to happen. So build this at your own risk. I'm just kind of throwing out an idea, something I think might work. And that, of course, would be bolting some large pieces of lumber together. And you can always put a few more bolts in. This has 2. You could put 3 or 4. You could put metal brackets on the back of it for some extra support. And of course, you could always put some braces under it. Maybe a wood post under it, the middle of it, for some additional support. That's where it would be the weakest. You build something like this, and it would tend to have problems more in the center. Or even, a couple of posts might be needed on longer stairways. Now, just simply a 8 by 16, this is 7.5 inches by 15.5 inches. Large piece of lumber, and just bolted together with some all threads. And I think in the diagram here I'm using 1/2 inch all threads. And you can just see there's a washer and a nut at each end. And again, like I said, you might need 1 or 2 more of these depending on the stairway. And of course, you might need larger pieces of lumber for something like this. Instead of something that's 15.5 inches, you might need something that's 16.5 or 17.5 inches. Or even a little longer, depending upon the step. 7.5 inches is pushing it for the riser height, and that might not even be something that would be approved on a public stairway. I think a public stairway is 7 inches. Private is 7 3/4. Keep that in mind. I do have other videos on that. You could attach the bottom into the concrete slab with another all thread and some type of an epoxy-based concrete system. And then, of course, you're going to want the nuts and the washers, or the top of the all thread, to be a little lower so that you can put plugs or some type of filler in there. I don't want people to be tripping over anything sticking above the top surface of the step. And again, like I said, throwing this out there, seen it done before, think it'll work, but you'll build this at your own risk. Let's go ahead and take a closer look at the block, what might need to be required. So here's what the all thread might look like. Of course, I don't have an all thread here. This is a bolt design. An all thread is threads all the way down. If you can get a bolt like this, it might work for you just fine. All threads are more common. And of course, bottom of it. Just wanted to give you an idea. Sometimes a few more pictures can help people out. That would be countersunk in a little bit to allow for the width of the washer, top view of it here. And if you drill these holes the same distance, I think I have it here about 1.75 inches away from the edge. But yours might need to be different, might need to be a little deeper. And I did the same on the side here, and that everything lines up that way. But you will have to figure out where to drill these holes. And in this video, I am going to attempt one more time to explain how individual riser heights can be created for odd-shaped or funky stairs. I've had a couple of viewers asking me questions about this. So most of the viewers understand how to figure out the risers for a straight set of stairs. And that can be done by counting the number of each individual riser. And in our case, we have 10 of them. And then dividing 10 into the total height or the total rise, and this will be the distance between the lower floor and the upper floor. And in our example, we are going to have 70 inches for our total rise, and if we divide 10 individual risers into 70, we get 7 inches. And 7 inches will be our individual riser height. And now you're probably wondering, why do I need to do any of this? And you don't. You can simply multiply the amount of risers to find the height of a step. Or you can use a story pole, and I have another video on that also. And I don't recommend creating what I would call a riser ladder here. However, if you need to, something like this can be done on a sheet of plywood or a couple of sheets of plywood. Just simply nail whatever plywood you need to some of the wall framing studs, or use the shear panel if you need to. And the benefits of having something like this will be to provide you with the top of the riser height. For example, if I have 7-inch risers, I can simply multiply 7 times 3 to find out the height of the third step. However, if I'm dealing with fractions, maybe 7.3 or 7.37584, then it might be more beneficial to create a story pole or a riser ladder like this one. That way you can simply grab your tape measure and measure from the top of the floor to the top of the 4th tread, instead of doing any type of math. And when it comes to complicated fractions or long fractions, something like this might provide you with a good way to handle this. And I'm not about to suggest that you build a stair ladder out of whatever materials and then use it like this. However, this is just another way that I can use to explain a little bit better how this might work. And if each one of these lines represents the distance between the steps, and our distance is 7 inches, then you can see here how a stair ladder, an imaginary stair ladder hopefully, will provide you with the individual riser height location from the top of the tread to the ground. And again, a story pole will work just fine if you understand exactly what you're doing with the story pole. So again, you're looking for the individual height of each step off of the ground, and you could probably do it with a story pole a little bit easier than you can with one of these riser ladders. And here you can see where 1'9" represents 21 inches, or 3 times 7. So again, is it going to be easier for you to use a calculator or a story pole, or do you need to take it a step further and create some type of a riser ladder like we have here that will represent the width of the stairway along with the top measurement for each step? And this could help you a lot if you're having a difficult time figuring out the overall height of a particular step or a landing. And in my opinion, I think this is where people get a little confused, and the illustrations in this video might be a little helpful. By rotating our riser ladder 45 degrees to create a few more points of reference that you can use as a beginner stair builder or even a professional who might be having a difficult time imagining all of this stuff inside of the brain. And hopefully this makes sense if you are going to add another crazy step to your crazy stairway by creating the reference points again, if for whatever reason they are needed. And hopefully by now you are starting to wrap your mind around this, because this is going to be the last example I'm going to use for our project here. And by now you should understand how to get the height of each step by either multiplying or using a story pole, or even with your stair riser ladder. So hopefully this makes a little more sense to those of you who are having a difficult time once the stairs are no longer straight to figure out the individual riser height or the overall distance between the top of the floor and the top of the step. Here is another video that one of our viewers requested. And even though I won't be going into all of the details here, I'm not going to be breaking out the pry bars or the sledgehammers and the chainsaws. However, I will be providing you with very basic instructions on how you can take apart most stairways. And that's going to be by simply reversing the assembly process. So let's go ahead and get started by removing each one of the stair steps. And even though I do not suggest that you stand on any part of the stairway that you are removing, I have done it before, but I know what I'm doing. So this process right here, where we're taking apart the stairway from the top, might not work for you. And you might want to take the stairway apart from the bottom so that you won't be standing on it during any time of the demolition. And of course, that would look something like this here. And another thing I would like to point out is that you can remove the center stringers before removing the outside stringers to give you room in here to walk around. And this will definitely be beneficial if the stringers are attached to the wall framing on both sides. And even though I won't be providing you with examples on how to do it, you can always use a saw to cut the stairway components into smaller sections. For example, if this stair stringer is attached to a wall, I might want to grab a circular saw and cut it into smaller sections to make it easier to remove from the wall. And don't forget that prying something, if I grab a pry bar and I get it behind the stringer and I'm trying to pry it away from a wall that I don't want to ruin, it's drywalled on the other side or it might have tile on it, then you won't want to use a pry bar because you could damage the wall finish on the other side. And this is where cutting it into smaller sections will benefit you. So remove the inner stringers if that's going to work for you, or the outer stringers first if that's going to work better for you. And if you have a stairway with risers, then you're just simply going to start from the bottom by removing either the tread first or the riser first. So in this example here, we remove the tread first. So tread, then riser, or riser, then tread, whatever's going to work easier for you. And of course, you could always remove all of the treads first and then all of the risers second. And yes, even though it's hard to believe, it wouldn't be a bad idea to create some type of a plan to demolition your stairway. And the last suggestion I would like to make is to be safe, something that people say yet might have a difficult time understanding. So you might consider hiring a professional if you're not comfortable or some of the information in this video doesn't make sense. Here's a problem you could have on older stairways, for example, stairs built before the year 2000, I'm just guessing, where the risers are open, where a 4-inch round sphere or a ball, for example, could actually pass through on a set of stairs. You are not allowed to have a 4-inch round ball, for example, pass through any part of the stairway, the guardrail. This wouldn't be the handrail, but a lot of people confuse the handrail with the guardrail. And a good example of this is actually the riser itself. This type of stairway, and I built plenty of them, and we never used to have to block them off, but it's actually a building code now. If you need more information, you can always visit the website and check out the building code area. This is method one, and I would imagine it is the best way to solve a problem like this, the cheapest and most effective as far as I'm concerned. You would actually take a board and attach it to the back of your treads. And a lot of times we use 3x12s or 4x12, something like this. We have a nice wide area. You could take and attach a 1x6 or something like that to the back of the tread and put some screws in it, and you really have a nice solid piece. Here you can see where the ball cannot pass through the stairway, and this something like this would, like I said, meet most building codes or satisfy most building authorities. However, remember, and this is a thing I'd like to try and point out in a lot of my videos, I'm not a structural engineer. Some of you have told me, God, I'm tired of listening to that. You tell them this, you're not a structural engineer. Well, I am not. This is just information I'm providing you with that is helpful, something I would view as helpful. But it does not guarantee that you could use any of these methods in your area. So you always need to check with your local building department for clarification on any of the information that I'm providing you with in these videos, and obviously other videos also. In this example, you could attach a board to the bottom of a tread, and this would also be effective. Something like this you could actually attach to the bottom of the tread with some long screws, and I would imagine that would be effective. You could actually attach the screws from the bottom or the top, something to where you could firmly attach the riser blocker, we will call it. Another method would be to seal off the riser entirely, and you could use a 1x or a 2x for something like this. I actually did a job one time where I built a stairway like this. It required a real heavy-duty stairway. It had like 6x14 stringers, 4x12 treads, and I needed 2x8s for the risers, and this was for a fire. This was actually a fire egress stairway, the one that I built. So you might need to consider that also when blocking these risers off, whether or not you need to actually use a 1x8 or a 2x8. And again, these can be attached to the back and through the top. You could drive some nails in through the bottom if you had the right. Obviously this isn't going to be easy if you have a 4x12. You're not going to be driving nails through the top, but if you do have 4x12s, these are 4x12s or 3x12s, you could actually toenail into the back of them, nail into the back of the tread, with your nails going at a 90-degree angle in, and here they could go in at a 45-degree angle. Here's a better example of what I'm talking about. You can actually drive a long nail into the top of the tread or a long screw, and this might require you to drill a hole and countersink the screw or the nail also, because any nails that stick up could be a problem. Just like any little divots, if you drilled too big of a hole or too wide of a hole here, it could create a problem for someone. They could actually get something snagged, part of their shoe or something, and it would be a safety hazard. You could always attach a 2x to the back of the tread, screw or nail something into the bottom of the tread, and then come around in the front and then face nail into that. Last but not least, you could always use some type of a hardware and screw or nail, whatever you would feel would be appropriate, into the back here. This would be something you wouldn't see, but could provide you with with a nice structural support. Here's the last and final method I would like to suggest, and this would work if you have, a lot of times you're going to come to a stairway like this. It's going to have concrete or metal treads. something like this might be your only alternative. You could use a piece of wood, and you could always get something custom made if you wanted some metal. If you, let's just say you had some metal treads and you wanted everything to match, you could always get something made that you could, that would block the riser and attach firmly into the stringers. Something custom made at a metal fabrication shop. Something like this wouldn't be that difficult to put in. Maybe a 2x4, maybe a 2x3. And then you could always attach it with some type of hardware again. Just wanted to show you here that in the example I'm using a 2x3 and I moved it back a little bit. It doesn't need to, remember you can block the stairway off, and if you moved it back a little bit, this would give you a little more room underneath the treads to walk up. A lot of times when we walk up a stairway, we don't like to have 90-degree angled treads. That's why we have the 1-inch overhangs or the 1-inch nosing. So something like this could move back a little bit. Remember, just as long as the ball isn't able to go through it, or the 4-inch round sphere. So it actually could move farther back than this. And it could move farther forward. This would be something that you could use your own discretion on. And thanks for watching. Don't forget to check out some of our other videos on YouTube. And if you can't find the videos on YouTube, make sure that you visit our website to find a complete organized list of all of the videos we've made so far.